Hey, welcome to a video on section 3.8 regarding the inverse matrix and solving systems of equations using the inverse matrix. So before we get into what an inverse matrix is and how to actually use matrices to solve a system of equations, we do need to have a discussion about the identity matrix. The identity matrix seems pretty basic. For 2 by 2, you see here you have like 1, 0, 0, 1, or 3 by 3, you have a 1, 0, 0, 0, 1, 0, 0, 0, 1. Basically, it's kind of like multiplying by the number 1. For example, 5 times 1 is 5, 4 times 1 is 4, 3 times 1 is 3, 2 times 1 is 2. So whatever number that's multiplied by 1, the identity stays the same. And that's what's going to happen when you multiply a matrix by the identity matrix. The matrix will stay the same. That's why I call it identity. You might remember in geometry doing like the reflexive theorem or identity theorems and stuff like that, where things stay the same, or reflexive identity when you say like, oh, angle A equals angle A. That's kind of what's happening here. So for example, let's say I multiply this matrix 1, 4, 3, negative 2 by the identity matrix. And by the way, an identity matrix has to be a square matrix, meaning that the rows, actually let me rephrase that, the number of rows equals the number of columns. So you can't have like a 2 by 3 identity matrix. It's impossible. Has to be 2 by 2, 3 by 3, 4 by 4, 5 by 5, and so forth. So if I multiply matrix A with this right here, by the way, sorry if you hear an echoing effect. I'm actually in my office in the main building, so I do have a second office, believe it or not. So, and there might be a question on the Google form, so take note of that. So we have this row, this column. If we multiply that out, that's 1 times 1 plus 4 times 0. Then multiply the first row of the second column. So that's 1 times 0 plus, hold on a sec. I made a mistake here. Something seems a little fishy here. Give me 1 second. Oh yeah, no, we're fine. Plus 1 times 4. Sorry, I'm tripping. 3 times 1. I'm tripping so bad I can't write my 3's anymore. 3 times 1 plus negative 2 times 0. And 3 times 0 plus negative 2 times 1. Okay. So the result should be what matrix A is. 1, 4, 3, negative 2. So it didn't change. If you reverse the order of it, it doesn't matter. So for example, I multiply this row with this column, right? So 1 times 1 plus 0 times 3, 1 times 4 plus 0 times negative 2, 0 times 1 plus 1 times 3, 0 times 4 plus 1 times negative 2. What do I got myself? I got 1, 4, 3, negative 2. Stays the same. So that's what happens with the identity matrix. Now, why is that important? Because let's talk about the inverse matrix. So the inverse matrix is kind of a really weird thing here. And I'm trying to find the right words to kind of explain what's happening with this. Let's actually take a look at matrix A. So matrix A again was this: 1, 4, 3, negative 2. And say I punch into the calculator and I want to find the inverse. So I'm going to get my calculator out. And if you want to try it at home, you can as well. And what you're going to do is you're going to raise it to negative 1 power using the exponent feature in your calculator. So go alpha zoom. We talked about it in class at 2 by 2. So 1, try that again. 1, 4, 3, -2. And I get something really weird. I get a bunch of decimals. I get like 0.14 and then 0.21. Sorry, my computer sometimes freezes up. 0.21. And it's kind of hard to read. Geez, it's not really showing the other one. So I'm gonna convert this to a fraction. If you hit the math button and you'll see frac selected, you can actually convert your answer to a fraction. So I think you get this. So after you raise it to -1 power, and then you get these weird decimals, hit the math button, hit frac, and it'll take the answer and make it a fraction. So you get 1/7, 2/7, 3/14, and -1. So that's the inverse. How that is found, if you're curious, it's a really kind of funky thing. You have A, B, C, D, and you take the inverse of it. You're actually doing something kind of like this. I think I've done that correctly. I'm not 100% sure. But don't worry about that because I'm not going to ask you to do it by hand. We'll all use the calculator. But here's what I do care about. You do take matrix A and its inverse, which was this 1/7, 2/7, 3/14, -1/14. And again, remember, we found the inverse by taking our matrix 1, 4, 3, -2, raising it to -1. And after I hit enter, I did math, frac, and it got me that. Now, if I were to actually multiply this out, if I were to multiply this row with this column, here's what's going to happen. You're going to have 1/7 plus 12/14, which actually is 6/7. Then you have 2/7 minus 4/14, which reduces to 2/7. Then you have 3/7 minus 6/14. 6/14 reduces to 3/7. You have 6/7. 2, because remember you have a -2 times -1/14. So when work it all out, you actually get 1, 0, 0, 1. Oh, look at that. That's the identity matrix. So what this tells us is that when you multiply the original matrix by its inverse, you get the identity matrix. And that's going to be very helpful when using this, when using matrices to solve a system of linear equations. If you reverse it, do the inverse first and the original afterwards, you still get the same thing. You can try if you like, but in the interest of time, we'll just move on. So why is that important? Because let's say we want to solve a system of equations using matrices. So first we have to organize it into a matrix. So A is going to be our coefficient matrix. And I asked this as a Google form question a while ago. I know it's kind of a tough question. X is going to be our variable matrix. And B is going to be our constant matrix. So what I'm going to do is the coefficients are 2 and -3, 1 and 4. My variables, of course, are x and y. And my constants are 19 and -7. This has to make sense because if I take this row and multiply to that column, I get 2x plus -3y. And that's going to equal 19. Then if I take this row right here and multiply by that column, okay, made it really worse, it's going to equal -7. So you get x plus 4y equals -7. So that's how we can organize our system into a matrix. Now to solve it, here's what's going to happen. We are going to have to find inverse of A. So if I actually go to my calculator, do alpha zoom, 2 by 2, 2, -3, 1, and 4, raise it to -1 power. You get these wacky decimals, so I'll go math, fract, change it to fractions. It's going to be 4 elevenths, 3 elevenths, -1 eleventh, and 2 elevenths. So that's that right there. Now, what I'm going to do is I'm going to solve this matrix equation using the inverse. So I'm going to do a -1 times 8 times x, and I'm going to multiply a -1 to the other side as well. So whatever you do to one side, you got to do to both sides, right? So this equation now becomes this, but what I've done is I've introduced a to -1 on both left and right sides. The advantage of doing that is that all this right here, as we just discussed, becomes identity matrix, becomes 1, 0, 0, 1. And of course, x is xy. So when I multiply it out, guess what? I'm just going to get xy. And over here, I'm going to multiply inverse 4 elevenths, 3 elevenths, -1 11th, 2 elevenths. Multiplied to matrix B, which was the constants 19 and -7. So all this just becomes xy, because when you multiply anything by its identity, it just stays as is. For example, this is a 2 by 2, that's a 2 by 1. Those dimensions match up, so I have xy. And if I actually multiply this to a 2 by 1, which has 19 and -7, I get 5 and -3. And those are going to be my answers. And then you can actually check it by plugging in 5 for x, -3 for y. You'll see it works. So it's that kind of a cool technique. You can use matrices to solve systems of equations. It becomes very, very handy once you start dealing with like 3 equations and 3 variables, or really nasty coefficients like this one right here. So we're actually going to try this right now for some of these problems. So again, if I organize this into a matrix, 1/2, 2/3, 5/12, 7/12. The coefficients, sorry, my variables are x, y, constants are 5, 6, 3/4. What happens is that I have to multiply both sides by the inverse. So you actually want to show it. And the order in which you do it does matter. So I'm putting it to the left. Even though I did say the inverse in its regular, the order doesn't matter. But because I'm forced to put it on the left side of the left side of my equation here, I'm forced to put on the left side of the the coefficient matrix. I'm kind of forced to put this in this particular location. I got to put it in the same location on the other side of the equation. So that's my inverse of 1/2, 2/3, 5/12, 7/12, 1/2, 2/3, 5/12, 7/12. And I know all this is just going to be the identity. I mean, you can work out if you want to. And on the other side, I'm going to actually do a 2 by 2. I'm going to put 1 divided by 2, 2 divided by 3, 5 divided by 12, and 7 divided by 12. Raise it to -1 power, and then multiply that to a 2 by 1, which is going to be 5, 6, and 3/4. And I get -1 and 2. We'll practice in class if you're having trouble with the calculator, but again, alpha zoom, that we locate the matrix. We're gonna, I did a 2 by 2, of course. I punched in those numbers, and then I did the x to -1 button to raise it to -1, and then of course, then I multiplied it to another matrix, a 2 by 1. And you didn't have to use multiplication symbol, you could just start writing the next matrix afterwards, and you should get that. But if you have a hard time doing it, we'll demonstrate in class, but at least you're seeing the video and seeing how this can be done. For 3 by 3, you just do the same thing. If you try solving this by hand, good luck to you. It's going to take a while and you can easily make mistakes. I'm not forcing you guys to solve this by hand because that's just not right. So see, now I did x, y, z as my variable matrix. I have all these coefficients here. So I kind of work it all out. So alpha zoom, I've now got myself a 3 by 3. All right. So 2, -1, 3, 1, 2, -5. There's also an app in the calculator that does this pretty nicely. The app is, and it uses matrices. It's called this. And I'll show it to you guys in class when we meet again, which will be tomorrow. Raise that to -1, and then have a 3 by 1, 5, -11, and 10. Okay, the numbers come out pretty ugly. I want to make sure I actually did this correctly. It looks like I did. And so be it. I guess that's what we get. No, something doesn't seem right here. No, actually, it seems right. Yeah. So if I go math frac, maybe converts to fractions. Yeah. X is -7 19ths. Y is -61. So I'm doing math frac afterwards, and it should look like answer arrow fraction. So it's giving me answers and fractions. So that's how that one works out. And then here, we have a word problem where we have baskets, basic baskets, 2 movie passes, 1 microwave popcorn. Good Lord, it's a lot of money, $15.50. Premium basket gets that, and a DVD. Ooh, and a deluxe basket gets even more stuff. So it's 3 unknowns, right? X would be the number of movie passes. Y would be the number of popcorn packages, microwave, D would be the number of DVDs, and then the model, like basically, just cost of each item added up equals the total cost. So for example, for basic basket, it's a, and darn it, I made a mistake here. It should be the cost of 1 movie pass, the cost of 1 popcorn package, the cost of 1 DVD. My bad. So that's the unknowns, not the number. So for basic basket, you have 2 movie passes. The cost is X for each movie pass of 2X plus Y. For the premium basket, 2X plus 2Y plus C equals 37. For a deluxe basket, 4X plus 3Y plus 2Z equals 72.5. So now we write the matrix equation. 2, 1, 0, 2, 2, 1, 4, 3, 2, X, Y, Z, 15.5, 37, 72.5. Now again, if you try solving the system by hand, you have to use a lot of substitution or some elimination. Like maybe you could isolate y for the first equation, y equals -2x plus 15.5. Substitute the other equations, then you get this system with x and z in it, and solve that. That's just too much. Just easier. Just realize x, y, z is going to be the inverse. 2, 1, 0, 2, 2, 1, 4, 2. raised to negative 1 power of 15.5, 37, and 2. And we'll work all that out and we'll end the video. So we got ourselves a 3 by 3, 2, 1, 2, 2, 1, 4. So you're going to practice this. So if you have a hard time kind of following along, it is a tough video to do without really seeing the calculator. Definitely you'll have a chance to practice in class. So we get X is 7. So maybe past the $7. Popcorn packs is $1.50. And DVD is 20 bucks. So now we get the price of each. So this way, if you have all this data on something and you want to figure out the cost of the items, you can kind of figure out this way. So matrices can be very, very powerful. And we're just still scratching the surface, believe it or not. There's a lot of other things we could do with matrices, but this is as far as we're probably going to go in this unit, and actually in this class with matrices. But we'll spend some time talking about it on Friday and early next week. Okay, that's the end of the video. Okay, goodbye.